Hello and welcome everyone to the Get a Jumpstart on OCI Anomaly Detection hands-on workshop. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to show you how to build your machine learning model to detect anomalies in production with a few simple steps. If you do not currently have an Oracle Cloud account, we encourage you to create one now. We'll be recording today's session, so if you'd like to follow along with the lab walkthrough and then complete the lab later on at your own pace, we'll be sending the link to the recording in the next couple of days, and it will also be available on the Modern App Dev series page and the Oracle Developer YouTube channel. You'll also have the opportunity to participate in a short quiz on the material covered in today's lab. Upon completing the quiz, you'll receive a Developer Masterclass badge that you can share to your social media, recognizing your commitment and earned expertise. If you have any questions during the lab, please ask them in the Q&A area and we'll answer them throughout the session. Today's lab will be presented by Ganesh Radhakrishnan, the Principal Product Manager for Decision AI Services, and Jason Ding, Principal Data Scientist for Decision AI Services. So without further ado, I will turn it over to Ganesh.
I'm, as Tara mentioned, I'm a Principal Product Manager for Anomaly Detection Service in the OCI AI Services team, and I'm also joined by my colleague, Jason Ding, who is the Principal Data Scientist in our team as well. Moving on to the next slide. So let me start by defining what anomaly detection is. Anomaly detection is the identification of critical events or observations in data that could differ significantly from the expected values, right? So anomaly detection applies to a myriad of scenarios like asset monitoring, maintenance, and across industries such as utility, aviation, transportation. There are wide-ranging use cases for anomaly detection in pretty much every industry. OCI Anomaly Detection is a PaaS service which allows customers to quickly train business-specific anomaly detection models using historical time series data points. And these data points can be received from sensors that could be connected to infrastructure resources or integrated medical devices or IoT edge devices. And data from these sensors can then be streamed to anomaly detection APIs in real time to detect a system level as well as component level failures. So essentially, OCI Anomaly Detection allows customers to create a scalable monitoring and diagnostic systems based on the anomalies and their severity scores. Applications can then take, can be written and programmed to take corrective actions. And OCI Anomaly Detection can detect anomalies in both univariate as well as multivariate signals. It is important to understand the difference between the two. With multivariate signals, there could be a correlationship between the signals. An example could be data collected from a sensor that is connected to a smart meter, could be affected by the weather or the temperature. So there is a correlation between the temperature and the signal that's collected. On the other hand, univariate signals have no correlation with other signals. In univariate signals, there could be a temporal relationship between the occurrence of the event at particular timestamp. An example that I could cite here is the classic credit debit card fraud detection scenario. So detecting anomalous events when multiple transactions occur within a short span of time. There is a temporal relationship between the events that are occurring. And these kind of events can be easily detected using univariate anomaly detection. So underneath the covers, anomaly detection uses MSET2 algorithm for multivariate anomaly detection. MSET stands for multivariate state estimation technique. And this algorithm was primarily developed at Oracle Labs. The algorithm has close to like 150 plus US patents and is widely used in nuclear power plants and aerospace industry to identify anomalies and take actions and do preventive maintenance essentially. The algorithm is tried and true and well tested over the past 25 plus years, and it's a proven technology. And just for statistics purposes, MSET2 is currently used in approximately 450 nuclear power plants worldwide, and 90 of them are here in the US alone. Moving on to the next slide, I want to spend some time and talk about the three main differentiators for OCI anomaly detection. Starting with the first one, it automates data pre-processing. So time series data often has got data quality issues. The data can be missing values for some signals, or the data points for some signals may not have synchronized timestamps. For example, the data sent by one sensor could be happening at 30-second intervals. The other data sent by another sensor could be collected at 45 seconds or 50-second intervals. So the data timestamps, the data points that are collected from the sensors may not be synchronized. Also, some of the signals may be quantized, meaning their values may come in as constant values versus row signals. And OCI anomaly detection automates data identification and also fixes these kind of quality issues, so the resulting models can be more accurate and they can make more accurate predictions. Secondly, the anomaly detection service, OCI anomaly detection service, is a developer-focused service that automates a lot of the data science tasks. The output of model training step presents important data to the developer or the business user, and they can understand and see whether the model is really the best model for them or not. The model training output helps like developers to fine-tune the accuracy of the predictions by fixing specific data quality issues. And if the model accuracy isn't good enough, then the developer can then see which data quality issues they need to focus on and then build a better model. Right. And the third key differentiator is anomaly detection can be used to automate business workflows. Every anomaly is presented with critical information, or we refer to them as explainability features, such as the estimated value, which helps to learn how severe the anomaly is, aggregated score, which indicates whether anomaly is getting worse over a period of time, and the signal specific score, which helps to assess the severity of the individual signals. Having all of this information actually can help to automate downstream business applications and business workflows. Applications can be programmed to take corrective actions quickly whenever anomalous events are detected. Moving on to the next slide. Oops. Probably skip through some of these slides and go to this slide. So how can developers and applications consume the anomaly detection service? There are two simple steps. The first step is to actually train an anomaly detection model using business-specific data. So every business or every customer may have data that is collected from sensors, etc. And these, this data, time series data, can then be used to train a specific anomaly detection model. Once the model gets trained, the next step is to actually infer or detect anomalies from data points that are received from sensors and other devices in real time. So you basically collect the data from sensors and then send them to the Detect API. And the Detect API will use the model that was trained with historical data to infer anomalies or detect anomalies in that data. And then based on the anomalies detected, you can introspect the severity score levels. And then based on the severity scores, you can take well-informed decisions. And the way to consume OCI anomaly detection service can be actually consumed in multiple different ways. We expose a REST API so that applications can directly consume the REST API. We also ship several SDKs for pretty much all of the popular programming languages out there. We have an SDK for Java, JavaScript, Python. You can see the list there on the slide. And we also support a command line interface as well. So this was a very high level overview of what anomaly detection service is. And if you have any questions, feel free to reach out to either myself or my colleague, Jason. And we also have a few links for useful online resources here, like blogs and reference architectures that you can refer to. With that, I will actually turn it over to my colleague Jason, who will actually walk us through some of the hands-on labs in terms of how to train a model and then how to detect anomalies from the trained model. Over to you, Jason.
Okay. Good morning, good evening, everyone. Again, thank you for joining. So I will be do some kind of hands-on demo to show how to use our services and using the UI to build them to go through all the end-to-end process of upload the data, and in the end you're doing some detection to observe some anomaly results. Right? And we also cover some kind of a programming if we got time, and also the command line tools to use interactive with the service. We do have this tutorial live you can access to. I think Tara is sharing in the chat. And we also, I believe we also sent an email earlier, so you can get a free tenancy first, and then you can use our service, right? You don't need to pay for it, at least for some time, and you have some credit to use it to explore the services, not just AI, but also other Oracle Cloud services, right? So I hope you might already start it. If not, that's fine too. So I'm going to walk you through to get it set up and explore our AI anomaly detection service. Okay. So right now, I think we ought to share the link, and we can also I can share it one more time in the chat. And we have total. We have around 6 live sessions. We're likely going to cover the first 3, and that's going to be using the UI to do some hands-on work. And then, like I said, the last 3 is a little more advanced using program language and also a more data analysis task. If we get time, we can cover it. If not, you can feel free to explore it and try on your own time. So first, like I said, help you already create some account, but if not, you can follow through these steps to, I think Tara also shared a link to sign up for, so there a referral link that will be more efficient to sign up. That way, you will enjoy all the free trials. Yep, thanks Tara for sharing it. So once you create your free trial account, and you will have the permission to see our service, you just need to sign with their cloud account name, and use the username and password you created, and log into the service. Once you log in, I should say something like this, right? Some console saying you are logged into Oracle Cloud. Is anyone have issues, or you already done this? That'll be awesome. If not, we're gonna move to the next. Any problems so far, and then maybe Tara or colleague can help. Okay. If not, let's move on to the main content. So first, a little bit introduction. I'm gonna give some intro. So we also have the brief intro on the lab session, and tell you what the user case, what the service is about, and also what typical industry are using the service, and what kind of business scenarios. So we have a YouTube demo as well. You can feel free to watch it in your own time, and then there are a few concepts I want to cover first, right? So just similar to other Oracle Cloud services, we have a few concepts in the anomaly detection service. So first is a project, right? Project is kind of a workspace for you to organize some data assets, models, and detection endpoints and results, right? Then you can create multiple projects in your tenancy. And then you can create multiple data assets as well. So data assets is an abstract data format to contain some meta information to point to the actual data source. So we currently supporting, Oracle Object Storage, Oracle ADP database, and InfluxDB. So anomaly detection service is that we build is using your data to train the model, so that the model will be much more accurate to and fit into your scenario, right? It's not like some other AI service, like maybe vision or language. They are kind of generic. It's a pre-built model. For us, we are in the current release, we are building a specific customized model for your data. So that means we need data from your use case, right? So that's why we need data assets, which you upload the data and then set up the assets pointed to that data, and then later on we can build model. Okay. And the model, we also have concept about model for sure, right? This is again, we have machine learning engine in the backend to build a model on your data set. Again, that the main algorithm is Oracle patent algorithm called MSI2 that Ganesh just mentioned. We also have other kernels as well in the kernel release, particularly univariant kernel. And later on, we may add more as we find more efficient kernels, right, for different use case. So finally, detection, right? Once your model is trained using our service, we automatically deploy that model in the cloud and provide you an endpoint so that you can streaming or sending more data and call the API and use the cloud console and to observe any anomaly being detected from the new data, right? So it contains all these steps and in the service so that you can start from the beginning of the data and to the end you're doing detection, so it's all covered. So the process, like I mentioned, it's also matching to the concept as well, right? You need to first to create a project, right? Maybe you have different business unit, you want to build different use case, you can create a specific project for that, right? And then you may have multiple data assets or one, you need to create that to point it to the original data source. And then you just a few clicks and set up some parameters, and we will start training the model. It may take 5 or to 15 minutes to train the model, but it could take a longer, depends on how large the data set, right? If you have millions of records, then it's definitely going to take long. So finally, like I said, right, the detection with new data. So you can send us new data and to the UI or from the API, then we will provide the results. So again, right, one project can have multiple data assets, right? You can run some experiments and build a couple models and find the one with the best performance, and then use that one, right? So you could have multiple model data assets or models in one project. You could also have multiple projects, right? To separate different user case or different department. That's all up to you. So I would also like to, mention the anomaly detection kernels, basically the algorithm we are using. Like Ganesh mentioned, right? We have much variant kernel, which considering both the time series relation as well, and also the correlation between those signals, right? So this is the Oracle patented algorithm MSI2 being used by many years for prognostic analysis. It have a few techniques embedded in it that's do, for example, do the intelligent data pre-processing where we can automatically filling in the missing values, which is a typical challenging problem. And also like sequential probability ratio test and to give you a really reliable and early warning if there's some slow degrading anomaly coming up. And of course, the core algorithm is still MSAT, which, like I said, is considering both the time series relation and also the correlation between signals. So this algorithm kernel is working well to detect, pointing anomaly, contextual anomaly, or collective anomalies in a multi-variant data set with high correlated signals, right? And however, we have internally some requirement to say which signals should be considered as multivariate signals, right? So for example, we cannot internally computing the Pearson correlation to figure out are they highly correlated or not. If they are highly correlated, then the kernel gonna automatically select these signals to build this MSAT2 kernel, okay? So that is, and also we also have some requirement on, how many data points you need to provide. If you have too few, then maybe that's not enough for the algorithm to learn the patterns, give you a reliable results. So we also have those requirements. We do have a document as well, so you can check that what is the minimal number of timestamps and signals for multivariate kernel. Okay. And again, this use case for MSAT2, including manufacturing, IoT, transportation, etc. Right. So another kernel is called the univariate kernel. So for some signal that doesn't have a strong correlation, right? It's basically that signal is kind of more independent itself, but some users or some customers still want to detect anomaly from that signal, right? So we do, in that case of a kernel of a machine learning engine, we automatically choose univariate kernel to build models for that, right? And so in that case, again, the univariate kernel, it's a standalone. It's gonna use the same API, right? You don't need to configure it. We automatically select it for you, so there's no actual work. The algorithm so far, we also have one algorithm right now, but we're gonna add in more. The requirement for that is basically we require the dataset containing numerical values, similar as MSAT. We only supporting numerical values, categorical or nominal values are not supported. I think someone asking, what is the signal in this AI context? You can imagine signal is kind of like one attribute. Like in a typical class, let's say prediction or classification user case, right? You may, let's say you have patient, you have the disease, right? You may have their blood pressure or height, the male, female, so sex, age, etc. That's each individual feature is we call signal here, because we are typically facing, in this space, we're typically facing some IoT signals or maybe some signal measuring and the manufacturing or transportation, and to produce some numerical values. So that's what we call a signal here. So it's a similar idea as a variable or a feature in the machine learning domain. So, again, any question you can post this or colleague can answer it. So this is our requirement again, right? We have these two type of kernels automatically, apply it, and we will pick the best kernel for those signals, and also do the hyperparameter tuning to find the best parameter, and so that we can build a really robust model in the end. Okay. So that is a kind of brief intro on the anomaly detection kernels. Again, there's some restrictions or requirements, so you can go through it and to understand what is the minimal data point that's needed to build the model. There will be, if you do have your tenancy available, so we need one prerequisite before using the service, which is setting up the policy, right? So you have the tenancy, you need to configure the policy so that the user can use our service. And it's pretty straightforward. Basically, you can, once you log in, I can also show what I have done in my tenancy, right? So I do have my tenancy. So I'm it's my tenancy, so I'm the administrator, so I can do anything, right? So you basically need to set up the tenancy in identity and security and policy, and just add always the tendency. This is not this one. I think basically allow any user to manage AI anomaly detection family in tendency. So this is a word you need to configure it. I think I believe I'm the admin myself, so automatically I should have that permission. But if not, you just need to, let's say, create a tenancy and Anomaly detection usage. So it doesn't need to have doesn't like space. Okay. And then you can choose the manual editor and paste this line, or using a AD service, and click create. And that's it, right? Basically, anyone in your tenancy can use the anomaly detection service now. Okay, it's immediately effective. You don't need to wait. Okay, so that basically the prerequisite you need to config for your tenancy. And if you have different group, you can also add a separate group for customize the service. We also gonna use the Oracle object storage, so you may also need to add this line as well. Again, by default, there should be you should be able to use object storage, but just in case, we can add another line in the policy. And what was it? Okay, save changes. Yep, so you can have two policy here for, two statement here for this tenancy, basically using the AD service and also the object storage. Okay. So that pretty much it for, this is the initial intro and to set things up. Any questions for, again, you can ask the panel or using the Q&A button. So let's jump into the first lab. So first lab basically understand data and download data samples. Again, right? Our service gonna require data from you to build the customized model, right? That particularly fit for your business scenario. So you need to give us data, right? There's some data requirement. Again, we require data values to be numeric, right? And we're supporting CSV format and JSON format. And then we support the data to be in object storage or in Oracle ATP database or InfluxDB database. So currently we are supporting these three at the moment. And let's say in this demo, I'm going to use the CSV format, and I'm going to upload the data into Oracle object storage. So there's some requirement for how the data should be structured, and what is the minimum number of lines, or what is the maximum number of signals. So it's these are just explaining to you what's the requirement. Another thing to keep in mind is basically the high level requirement is, the training data that you want to build a model should be anomaly free. That doesn't have outliers, and should contain the normal business scenarios for all different kind of value range in those normal business scenarios. So we don't accept, if you have a anomaly in the training data, you should first remove them. We do have later lab 6 give us some ideas how to remove some outliers based on your domain knowledge or based on some basic statistic analysis. But here we do as an anomaly detection service, we require the data to be anomaly free so that we can learn this normal patterns, and later on during inference and during detection time, if the model observes some different patterns, then we can short out some anomalies. We're telling you something different, we're telling you it's going to be an anomaly, right? So that is a requirement. It's really typical in many other service, and also in some machine learning user case as well. In the future, maybe we will add an ability to doesn't have this requirement, but right now we do have this requirement. So to give you a sense about what the data should be formatted, so here's is a quick example to show you the CSV formatted data. So it's just a simple text data, and the first column has to be the timestamp, right? Because it's a time series based multi-variant anomaly detection, so we require the timestamp, and it has to be sequentially ordered by time. And then for the rest of them, it can be the the other signals or variables, right, in your business scenario, and the value has to be numerical. So in this case, you can see we have 5 sensors. This is like a user case, right? They have 5 sensors, and the values can be like this, and you can have missing values. For example, you notice here we do have comma, so that means here there's missing values. So it's fine. If you have missing values, it's fine. However, I think also, you shouldn't have all of them as missing values, right? If it's that case, there's nothing in the data, we can't detect anything, right? So for missing value, I think we require at least one signal have non-missing values, okay? So this is a CSV format. For JSON format, it's a similar idea, just structured a little bit differently, right? So we're gonna require the request tab, again, it can be inline, and then this is special for the JSON format. And the signal names in an array, and then the data point is formatted as a timestamp and values, right? So again, it's the same information, but just structured a little bit differently. So depending on your user case, you can use that, or depending on your developers, so you can pick different format for the CSV data. So you don't need to worry too much. We already have a sample data set here. So here we have a training CSV video, have 10 signal with the timestamp columns, and total with about 10,000 timestamps, so 10,000 observations. And another a small data set that has, again, has the same 10 signals, but structured in a JSON format with only 100 timestamps, okay? So first, let's download this the training data. So later we're gonna use it to train your model. Like I said, you download the data. We need to upload this data into object storage. Again, it's pretty straightforward. Go to storage and bucket. You can create a new bucket, or you can use your existing bucket. It's all fine, right? Let's say in this case, I download it, so let me upload in my buckets. So buckets underneath storage and buckets. Let's say, give a name, generate demo. And then just need to upload the data. We just download it, okay? Again, I download the earlier, it's the same training data, CSV data. Just upload, and then done, right? So this is data in the object storage, and later we will create data assets point to this data, right? So that is basically this lab session, and we can move to the, I hope this is slow enough you guys can follow. Even you're listening, you can try on your own. Should be pretty straightforward. So now it's the main content of them using the anomaly detection service, right? So okay, there's so here we want to create a anomaly detection project. So anomaly detection service is underneath an analytic and an AI menu, and then in this AI service group, right? So basically, let me navigate to that. Analytics and AI anomaly detection. Okay, I see someone say, is there a cap on the uploading data set? I think if this is a trial, so maybe some limited, maybe I forgot how much, maybe 5 gig or 10 gig, I don't know, but that should be decent enough for you to run some small data set, right? If you have like a terabyte, I bet that won't work. Even uploading will take a long time, right? So, okay, so this is a anomaly detection user interface, right? I already have some project created, but I can again create a new project, just create gen demo project. Okay. So it takes a second to pop it up. And there you go, right? So this, you already create a project, and then here you can manage, the models, and manage the data assets, and also show some metrics, etc. Right? So this is what I mean. Like, this is kind of workspace for you to group, the same user case or the same data sets for different models, right? In a single place, so you can easily manage and you can separate from different departments. So database, we already covered this, create a project. It's again straightforward. And second, we need to create data assets, right? Again, data assets is kind of like a metadata, a kind of a data pointer, right? So it's point to object storage, your database, etc. Right? So we need to create that. So later on, when train the model, we can use this data assets. So you just need to create data assets, and then when it pop up, you can select the data type. As you can see here, we're supporting object storage and ADP and InfluxDB. So I'm going to choose this one. This is demo training data assets. Okay. And then I'm going to choose, I create a bucket called gen demo, right? So this is the training data, a CSV file I uploaded, and then create. You have data assets. Okay. You can create more assets, right? Let's say if you have a database, and you have InfluxDB, right? And you can configure them probably. Again, we have documentation on that to show you how to use that. And InfluxDB was about 2 different versions. And database, you require the URL and then the password, etc. Right? You need to configure it. Okay, so this is data assets, and now we can start training models. So if you follow along this workshop, so now we can start training the model. I hope folks can try this now. This is gonna be jump to lab 3, right? Just need to follow along this, right? By default, I'm not changing any compartment, so you can ignore this compartment. So this is root compartment, so everything is on the root compartment, and nothing to change here. So I will click to train a model. The data assets you already created, so you can select it. If you you can also create a new data asset on the fly right now. Right, as you create it, it's still gonna save it, so we can use it later. Since I already have it, just need to select it and then give a name. Let's say this demo model. Okay, so there are 2 parameters where we leave a default value here. The first one called target false alarm probability. So basically, remember, like, we require the data to be anomaly free. That means they are normal operation values, right? They are not anomaly. However, to give the model, to give the machine learning a little bit of flexibility for them to be resilient, to learn a generalized pattern from your data, right? So they may make mistakes. So this probability is basically telling the model, hey, I do allow you, when you train the model, I do allow you to learn to generalize, but making some mistakes, but up to a certain value. So here it means up to 1%, meaning when you learn the patterns from the data, you should try to be learned as normal data, but if you incorrectly learn it, at most you have 1% of chance to learn it, right? Up to 1%. So it calculates at every signal level and then average across, all the across all signals. Okay. And so that's what this means, right? We call it like a false alarm probability, right? It's a chances that the model generalize the pattern and then make mistakes, right? You don't want to set this as bigger because that way later on you're going to have a lot of false alarms, right? Here you want to control it to be really small so that it's maintained in a reasonable value in your use case, right? The second value is called training fraction ratio. This is basically, it's really similar to any machine learning life cycles, right? Where when you're training a model, you put some data as a training set where you learn it, and then you use the rest of them to validate the model you just built, right? So here it basically means, we're gonna use 70% of data to learn the patterns, pick some useful information from that 70%, and then apply to the rest of 30% to validate. Okay, does the model really work well? Does it's really, detect no anomaly in your training data sets, right? In the 30% of training data set, right? This value can adjust to, between 0 to 1, but typically, between 50% to 95% is all reasonable, right? And we recommend to use 70%, which is applied to many general use case. So that's it, right? You can leave it as default and then click next and verify all the information is what you just said, and then create. And the model is start training. Right. So in the backend, we basically, set up some sandbox and pulling the algorithms and also connect to the object storage and putting the data into memory and run the algorithm and building the models and building multi-models and to find the best one, right? So again, this may take 5, 10, or 15 minutes. It could take much longer. Again, depending on the training data sets, right? For training, again, you could have in some cases, it could have a gigabyte data sets to train the model, right? So that definitely going to take longer. But you could also have, several, self-sovereign roles, which will be much smaller, maybe just 10K, 20K data file size, right, to train the model. So that will be much faster. So I won't wait for that to the results. I'd like to show you, what the detection looks like, and when you finish, what the model looks like. Let's go back to yeah. 1 second. I think I have another one where we have. Yep, this one just trained early this morning. Okay, once it's finished, so first of all, it will say active, right? So model is active. That means it's done. Okay. And then they will give you some model information. So first of all, they can show you, hey, we do have endpoints. You can copy and then start doing detection using API. And we also telling you, the model performance. For example, the target is this one, 0.01. You can see the model false alarm probability is less than that, right? And this value is computed at a timestamp level, so it basically consider every signal. If there's anomaly, it will flag as an anomaly, right? So this will be a little bit bigger than this one, because the first one is averaged at a cross signal. This one is kind of all the signals together at a timestamp level to see how many, what is the FAP value. And you can also download the model details to see the model results. I think I already opened it. So these are the results. So we're telling you, what signals and the signal name, what is FAP value we got for the signal, what is the mean and max value and standard deviation, and status. We accept it. We think this signal is relevant, is correlated, and we want to use it, right? In this use case, actually all the signals are highly correlated, so we are using all of them. And the value of this to give a context, later on when you run some detection, you may say, mean and max are totally different, so that means values are shifted, so they may flag it as anomaly, so it's not a surprise to you, right? And at the same time, if you observe this mean and max value, if this value, let's say, is really small, then maybe you will notice some data issues when you collecting those data, right? So you can immediately fix and build another model. So this basic syntax statistics to give some idea, is this making sense for your business user case, right? And also, is there something else? For example, if this signal is not correlated, is a constant, we're also telling you we're going to drop it because constant, it's not related to our signal. That's not helping to build the models. We'll tell you, it could be dropped. And actually, we also use that to flag if a constant value and later on you have another value, we also telling you something's wrong. You need to fix it, right? Because we observe constant, but later on it's a different value or it changes differently. So that way you can also immediately notice some difference between training and detection, so you can take some actions. So those are the model information if you download from the UI. And how do we do the detection, right? So detection, again, it's pretty straightforward. Once you build the models, you can navigate to this page, and you have a button called Detect Anomaly. And then you can select the file. Remember, we have two files downloaded, one in CSV for training and the other one in JSON. It doesn't need to be JSON, it can be CSV, can be the same format as well, okay? I'm just using JSON just in case people want to see how the JSON is structured, right? So when this testing data uploaded and click detect, and you will see the results, right? So in this scenario, you can in this scenario we are all signal correlated. It's basically building a one multivariant model, so it doesn't have any univariant. So it's basically all signal belongs to this multivariant model. So you can click this button to see which signal was used in which model. And let's navigate to one of the lines. You can say, so for example, this is a detection payload, have about 100 data points. There's like a degrading around this part. You can see this right vertical line, it's flagged it, right? So that means anomaly be detected in those data points, and we flagged it. There's another area here, it's been flagged it. And another area here is also flagged on this for this sensor, right? So you can see, we give a really detailed anomaly where it's coming from, right? Which signal it's coming from. So you can make more judgment in your user case where like you should take action to that particular signal or business assets, right? Imagine in some user case, you're monitoring the business assets, right? You may have multiple assets, and then if this signal is coming from particular assets, that assets have issues, you can go there and figure out what's wrong, right? So this really gives you really detailed results at signal level. It also gives you a estimate value, right? So that is really special for our service, where we're telling you the actual values, which is this orange line, right? And then we also give you the estimate value based on the model. So we estimate based on the data patterns. Those should be the values. And you can see they have a significant gap. So that's why we detect this as an anomaly. And then so that you can also use that estimate value and to use that in your user case, right? If that estimate are really different with the actual, then you can make your proper judgment as well. And we also give you a score based on the difference of estimate value and also the trend, right? So the higher the score is, the high chances that the anomaly is getting worse. So you should take more immediate actions. But if it goes down, maybe it means it's kind of elevated. We're getting back to normal soon, right? So this, again, you can leverage these scores to tune it to fit into a business scenario where you want to come to which action you want to take, right? Maybe small values you don't need to immediately send someone to look at the anomaly. But if it's a high value, you can say, hey, it's high priority. I need to immediately send someone to figure out what's wrong, right? So this is really detailed results, and this is on the UI in the API. You can also get the results, so you can click download JSON, and this give you the results for all the anomalies, right? Which is in this format. So we're telling you at this timestamp there's an anomaly from that particular signal. This is the actual value you're giving us. However, we estimate this should be this number based on the correlation and also time series relation, right? And also give you a score. This is pretty severe, and take some actions. And then we also give a score at across this multiple signal level, right? So in this case, only one in this timestamp, only one signal is detected as anomaly. So the score at timestamp level is lower. But if you have in some cases, if you have in this timestamp, there's two signals, right? Both detected as anomaly. So the score at that timestamp level is a little bit higher, right? So again, that can give you more information so that you can leverage to apply to your use case. Okay. So again, everything here you can see from here. You can see from the console, and you can also use the API to query and send detection payload and get the results back. Right. So that is kind of the full demo for the from training and to detection. Oh, another thing I want to mention the results. Like, let's say if there's missing value, we also telling you what is we estimate the value, right? So maybe sometimes it's actual value is missing, but we telling you we based on the relation we estimate it's in another value, we are telling you what it is. Okay. So that is the detection. So we go back to the tutorial. So we kind of finish this here, right? And we also explaining, what's meaning of the subgraph and what the scores is about and the results looks like. And basically, we're done this part. Again, use the QA if you have any questions. Use the QA button. Okay. So next one is basically a little bit advanced. So if you still following thus far, you can try to use programming to talk to the service, right? However, to do that, again, there's some prerequisites I think is sent out early. So you need to set up the API signing key, right? Like how do you connect to the service? We need to kind of authenticate you to use the endpoint. So if you have a tendency, you need to open the user settings, set up the API signing key. Again, that is pretty straightforward again, right? So basically go to the users. I think it's in here. Oh, no, identity and security and users. For example, I have a couple of users, but you can create a new users. But I think by default, it's yourself. So this is myself. And then I need to add API key. I already have two, but you can add more, right? and then they will automatically generate a pair. You just need to download this private key and click a button and say add. So you will add they will generate API key automatically for you, which is unique. Like here, you like in the beginning, you likely don't have anything, and then generate the key, and they were named as something with a timestamp. You can rename that PM file as this OCI API key. And next, you can use the we're gonna use a Cloud Shell. So if you don't have a Python Linux terminal, that's fine. So our cloud services give you a Cloud Shell as well, right? So it's pretty straightforward. So you just need to click the top right corner next to the region name. So that's Cloud Shell. So you just need to click, and then within maybe around 1 minute, they will kick off a Cloud Shell session, particularly for your user case, particularly for you, right, for your account. So for example, I now already have one, and I can use it. So so the next step is basically you download it. You need to copy this configuration, the content like this, and you can save that into your local computer, right? So again, I normalize the values, but it's following this kind of syntax, right? So you can save this as a text file. You can use text editor to save in your local computer, in your laptop, and later upload to this Cloud Shell. To use a Cloud Shell, again, I think by default you should have the ability, but if not, you need to add the permission. So to the policy, again, if you go back to this the policy manual page, so you can add the allow any user to use it. So that way you can activate the usage. So make sure to do that. I believe the first time if you click that button, if it doesn't work, it says permission issue, then that means you're missing this in the policy. Okay. Okay, and like I said, it's on the top right corner. So you're gonna have a Cloud Shell like this, and you need to upload the PM file that you just generated, and upload. Okay. So for example, here, upload, and select from a computer. Think I can do it. Let me try this, right? Save it, and then click add. Once you download it, click add. So that way it's generate a new one. Then you need to copy this content. Okay. I'm gonna save it here. And K file is the file. Is a file. It's just downloaded. Okay. That's in my download. I think this one, I'm gonna move it to this demo data so that easily access to. So this is a PM file. And I'm gonna go back to my editor. I'm gonna do this. And save this as let's say a new config or generate config. So now we need to basically upload those two files. One is general config, which is just 5 lines. The other one is the PM file. Okay. Upload. Okay. Once you do that, you need to move it and change the mode, because that file need to be only read by yourself. So I'm gonna change both of them. Gonna move them to. I think before that, if you don't have it, you need to make a directory called .oci. Remember this dot. Okay. If the dot exists, then you don't need to do it. So .oci. Okay, it's there. So that's pretty much it for the first two tasks. Kind of set up the API assigning key, and then task 3 is basically leveraging our Python SDK to use that assigning key and to talk to our service, right? So you need to download the code here. Again, you can click download. I'm going to save it. And I already opened it before. It's a Python. This is a Python SDK. We do have an OCI command line one later, but here it's the Python one. You can say it's pretty straightforward to read. So the beginning is kind of loading all the packages that's needed. Keep in mind that you need to import an OCI, right? If you're using your own laptop, not the Cloud Shell, then you need to install OCI package from PIP or some other Python library manager, right? But because I'm using Cloud Shell, the benefit of Cloud Shell is basically it automatically gives you the OCI package. Okay. So I think we have PIP streaming or the PIP list. So it automatically installs some package for me. You see here, we already have the OCI and some other packages. So I don't need to install OCI package myself. It's already here. So that's why I'm saying you can use Cloud Shell to easily experiment with our API. Again, if you don't, you use an own laptop, you need to download it, install it yourself. Okay. Once you download the code, again, you can upload it to the Cloud Shell or wherever you, again, the same process, upload that Python code. But before doing that, we need to make some changes, right? So this is we have the OCI library, it's installed, and you can call the classes inside that package. Then we are configuring. We have a few configuration in the beginning, so you need to set it up. So first, the username you need to replace. So in my case, I can type who am I? So it's my account name. So I need to replace it. And then actually, I was naming it called gen config, right? So that should be gen config. But if you just call config, then you just need to match to the 5 or 6 line file, right? That has basic information. And service endpoint, again, you can use this line, but depends on which region you are logged into. So you may have you sign up for, so you may need to change it. So in my case, I think I'm in the US Phoenix region. So I need to change this to the US Phoenix 1. Namespace, this is a object storage namespace, so you need to change it. it's unique for each tenancy account. That's also easy to find out, which is in storage bucket. And you can click any of the bucket. There's namespace. For example, here this is my namespace. Change it. And the bucket name, I was naming this as Gen Demo, right? So I need to change this to Gen Demo. Okay. Then training file is a demo training file, right? This is a name we uploaded, right? So we can use the same name. Compartment ID. So again, we are setting everything under the tenancy, so we don't need a compartment ID, but we do need the tenancy ID. So that's a little. I think we also have it in the config file. Config file have a tenancy ID on the gen config. So this is the when you set up the API, there's tenancy. This is the tenancy ID. You can use that. The config. And then and that's pretty much it, right? That's basically set up a few variables so that it fit into your tenancy, and that's it. Okay. So once you can save it and then upload to the cloud shell again, right? Upload. Select that file, upload. Okay. I already have it, so let me see. So I have this, and then once you have it, you can run it. So the content, if you're following reading also the code, it basically goes through all the life cycle of this using anomaly detection service, right? So basically, project, we're gonna create a test project, and then it will create the project, and then they will create the data assets. Remember, data assets here, it's only linked to the data. It doesn't help you to upload the object storage. So you may need to call the regular Oracle OCI object storage upload function to upload that data. So here I will expect the data already there. This is only creating assets pointed to that demo data CSV. Okay, it's creating, and then reading the assets, list all the assets, and finally we also do a model, build the model, and then also read the model information. And then finally, you have some dummy data, and to send a payload and running the detection and show it. And finally, it will delete everything. So I'm gonna run it to show you just at least for the beginning, because training model takes time. So I will show at least you can see it started creating project. So here, create a project called test project. Okay, and reading the project. So we can go back to the anomaly detection service and to see it's been created. This is one. So I created Gen demo here, right? This is the one just using the command line to create it. You can see data assets been created. Models probably going to come up shortly. But it's basically the same life cycle, going through all over that we did from the console, right? So you can use the API to do it. Use Python SDK to do it. So that is again like you can go through this document. It's pretty detailed to show you, which part does what, and hope Python is easy to understand, and you can see how what in the end how it's what it does. So that is lab 4. I think maybe you can still have a quick session to come up to cover lab 5. So for lab 5, it's the same process. The setting up the task is API key. We already did it, then we don't need to do it again. Active Cloud Shell, again, if I already did it, we don't need to do it again, right? So then we can just try the command line on Cloud Shell. I think I only have one. I had to kill it. Okay, so command line is basically type OCI Anomaly Detection -H. They give you all the details. Okay, what kind of a command line available for OCI Anomaly Detection? You can do data assets. For data assets, you have this sub command. Models have this command, and project, etc. Right? You can also move them over, update it, etc. Right? So if we follow through this one, you can create a new anomaly detection project by saying, an OCI anomaly detection project create, and again the compartment gonna be the tenancy ID, right? So let's say if we can quickly run it. So this is the command, but I need to change the tenancy ID, add the tenancy ID, which is from doing the API sign up process. Okay, replace that parameter, then we can run a quick command to at least show you we can create it. Yep, it's created. I'm telling you the ID, it's been created successfully, and time, date, etc. Right? So we go back here to say OCI, click to test, right? So this is the project we just created. So again, you can create data assets where it requires, the bucket name, namespace, and object name, right? And then you can put this in your JSON format text file, and then run this command to create it. And then same thing for training, just follow this format, and this require data asset ID that you just created. So you need to record the results, and then replace that this data assets ID here. Then once model is created, you just need to wait when it's finished, so you can detect anomaly inline. You can use the model. Each model have a unique ID, even though sometimes you may have one multi-variant model, but multiple univariant one. It's still same ID, so you don't need to go to different places to make detection. It's always, underneath the same model ID. And it gives the data and gives the signal names, and see the results, right? It's the same process, but much easier to use a command line. Okay, and you can, if you use other languages, you can also use other languages like Java SDK, or Ruby SDK, and JavaScript. But if you are more familiar with the OCI click, command line tools, so you can also just run some command line. You can quickly integrate our service in your business user case and start using it. So that is for lab 5. Again, I'm running a little bit quick. I know some people may not familiar with this command line, but we have all the details documented here, right? So you can how to set up, just follow the screenshot and follow it, and it should be straightforward to get the same results as I did here. Okay. So that is the the click to And finally, we also have lab 6, where we give you a little bit more tips about how to prepare the data. And like I mentioned, right? So we do require the data to be numeric, right? We don't support categorical and nominal yet. So you like in some user case, your raw data may have, for example, like a city names or zip code or brand, etc. And let's say some other non-numeric, non-time series features like size of city, population count, etc. Right? So or GPS location, right? For example, GPS location is static, right? So you need to remove them before calling out service. So here we're giving some tips to kind of how to prepare the data. In one example where we have 2 buildings for monitoring, temperature and I think and another thing, those sensors are kind of a normalized temperature. So you need to kind of split them properly. For example, if you have 2 buildings that have different patterns, completely different patterns, maybe one is really residential, another one is more office, right? So that pattern could be different. Then you shouldn't, in that case, you should not build this one model for both, right? Because if you do that, then the model, accuracy of position will not be high, right? Because you have different patterns. So that is some kind of tips we have here to give you some examples. Here we have like temperature and pressure for 2 buildings. And we basically want to combine temperature and pressure from one building to build a model, and then the other building as another model. So here it's basically using Python pandas data analysis tools, and you can run some quick analysis and to split the data, concatenate the data, or maybe run some quick analysis. And also when you need to, make sure the timestamp is sorted properly if you're mixing them, right? So some kind of pre-processing steps, right, help you to organize data properly, right? In some other case, maybe you ought to have them in SQL. I mean, in database where you can use SQL to sorting them and do pre-processing, that's also fine. But in the end, we if you use object storage, we need the data to be in a CSV format, where the structure is with timestamp and other sensors, right, in the CSV data, right. So here we also give you some tips on how to compute the statistic to get a feeling before you even use the service. You think it's reasonable. For example, in this case, we notice sensor 8 have a really small standard deviation, right? Minimum value and maximum value close to 0, or really small, right? So that means something's wrong. You may immediately check in what's going on. So we also give you tips to show the graph and to show you to plot the histogram of each sensor, so you get an idea that's making sense or not. So in this case, sensor 8 seems weird, right? It's same spanning. It doesn't. It may be a fixed value of some sort. And sensor 10 have a small range, but it may have some outliers around it already, right? So you can quickly run some graphic command to figure out if there's any potential issue on the data, and before calling the service, right? So in this example, we have like a couple signal observed. They are either monotonic increasing or monotonic decreasing. So in this case, that means this monotonic signal is not covering the full range of the business scenarios, right? Because it looks like maybe you only pick 1 month of data, maybe you pick 2 months data. It's not enough to cover the full life cycle of your business use case. So typically we require 2 to 3 cycles of your business data, so that we can learn the pattern well, and when we run the validation or testing, to give reasonable results. Otherwise, we learn something, let's say in the summer, and then you want to predict in winter. Of course, it's going to flag you a lot of anomaly. And you may say, why is this, right? The reason is basically it didn't have enough data, right? And another use case could be like, as mentioned earlier, basically your data may be fit, the patterns very different, and you're mixing them, right? So we're kind of requiring typically the signals of variables should come from the same business use case, like say from same business assets where they have a certain correlation or relation, right? So that way, when we learn the models, so the variables impacting each other, and they have a correlation. So when we say one value goes up or goes down, and we observe a different pattern, different behavior from another signal, we can tell something's weird, right? Something's is wrong. So I think that's the typical requirement in any machine learning algorithm, right? You have to learn the common patterns or existing patterns, and then you can generalize it and predict something new, right? You cannot immediately predict something new where you don't know the historical patterns, right? So yeah, here's some examples to you. In these two sensor seems weird. We kind of using graphic to show you it seems not right? You need to figure out either the reading was wrong, or data processing wrong, or data collection was wrong, right? Also, we show you a correlation heat map to see the correlation between every pair of sensor. Finally, we also help you, how to remove, let's say, split the data, formatting the data, or maybe remove some immediately outliers if you already know them, right? So for example, here, you can say, let's say, some readings should never be bigger than 5 or less than -5, then you can, filter them out. It's fine to filter some data out, even we are time series based. So even you're missing, let's say, you have different frequency in the signals, it's still fine. We don't strongly requiring you, like you need to give us data every second or every few minutes, right? You can miss in some minutes data and the model still perform really well, okay? But however, you definitely need to know you shouldn't remove too much of data during the pre-processing, right? Let's say if you remove like 10 or 15 of the data, then that means you already have so many anomalies in your business use case. You may need to fine-tune your use case to to navigate the real anomaly, right? But otherwise, if you really have a lot of anomaly, and then you train the model, and we're doing detection, we also give a lot of anomaly, right? So that may have impact your business a lot, right? Interrupt your business a lot. You have to constantly sending people to look into that. So finally, it's data formatting, and that's the two data set. After data processing, we have the data set that you downloaded earlier, right? So those are the two files you tried. I know we're kind of running a little bit fast because I really want you to try experiment the service and call it. And particularly if you already have the tendency ready and go through it, you can immediately build a model in the service in 15 or 20 minutes window, right? So it's really easy to use and easy to integrate, and we have this lab demos and also other documentation to help you to use the service. I think that's pretty much it. I think another thing I want to mention, right? So maybe once you build one model, maybe you see the value is as expected, or maybe later on you need to build a new models. And currently we don't support retrain the model, so basically you have to collect the new data and retrain the model and build another one, right? In the future, we may help you to automatically add a new data to train a model. But at the moment, right, like if you really want to retrain another model, you have to retrain it, right? And another thing is basically, like I said, we only support numerical, and we are requiring the data to be anomaly free. we also making continuous updates so that we can help resolve those problems in the future release.
I know that it was a lot of content to absorb in 1 hour, so we would request all of you to kind of try out the labs at your own pace and convenience. You will have access to the trial subscription for about a week, and I will let Tara clarify that. But thanks for joining and attending this event. Hopefully this was valuable for you, and you will be able to use anomaly detection service to build some solutions for your customers. And feel free to reach out to myself or to Jason. We will make sure that you will find our email addresses and contact information in the registration link that was sent out to all of you earlier. Thanks for joining, and just turn it over to Tara now.
Yes, thank you, Ganesh, and thank you, Jason, for the fantastic presentation. So we just have a few additional links here. If you enjoyed today's session, we'd like to invite you to join our next developer lab, which is on January 27th. And this will be on analytics and machine learning with Red Bull Racing to discover what makes a race the best of all time. And we also encourage you to share with us any feedback that you have on today's session and to contact us with any questions on the lab. So we'd like to test your knowledge on what you learned today. So by completing several questions of our lab quiz correctly, you'll achieve a social badge, which you can share on your social media. And so with that, I'll go ahead and end today's session. Have a great day, and we hope to see you again next time.